this video we'll discuss the use of bit memory and why its use in modern programs is a bad idea. You should never use bit memory because using bit memory is archaic. It's part of the old hardware of the old PLCs and it's only in the new ones for backward compatibility. Using bit memory is dangerous, it's got global scope and it's difficult to move things around. And using bit memory leads to unmanageable code because it's very difficult to upgrade PLCs with new PLCs because the memory addresses can change and so on. Data blocks can do everything that bit memory can do and it does it much more efficiently. We'll take a look in this video why. So let's look at what is bit memory first. It's part of the CPU's memory map. It's including the inputs, outputs and hardware timers and counters. The symbolic addressing of the bit memory is done in the symbol table together with a configuration of I/O. It's not done in the user program like a data block is. Bit memory is finite. The size differs from PLC to PLC from 256 bytes for the old small S7 300 series going up to 16 kilobytes for the new S7 1500 PLCs. The problem with it is it's a flat memory model, it's structureless, it has global access, and as such it becomes very dangerous and very difficult to manage. So bit memory limitations. The bit memory is dependent on the CPU's hardware. The power off retention is selected in hardware and it's based on the number of bytes rather than what data you want to retain. So if you're only retaining the first 20 bytes, well, sorry, if you got some other information you need to retain. The symbols for the bit memory is part of the project configuration. It's not part of the software, and that's a problem. And bit memory cannot be initialized at startup with default values, like a database can. So if you need to put default values in bit memory, you need to specify that in OB100. And then why are data blocks better? Well, main reason is data blocks can collect data into a meaningful structure. In other words, data can be related by the processes that it's describing or by a specific area. So if you've got different like a canning plant and a bottling plant and so on, the data can be related by function, whether it's a drive and a motor, that can be grouped by needs, by the needs of the application. So you can tailor your DBs to match and to represent your data in your process much better than you can with bit memory. Also, bit memory we saw was limited to 256 bytes in the smaller, older PLCs. Even those old PLCs can do up to 1024 dBs, each one with 64 kilobytes of data. So we can store a huge amount of data. The new PLCs, the S7 1500 PLC, can have up to 60,000 dBs, each of a megabyte. So what can DBs do that bit memory can't? Well, we can change the size of a DB without modifying unrelated parts of the program. We can add and subtract and change the data in a DB very easily without affecting the rest of the code. If you try to insert in a bit memory, if you try to insert spaces in memory, you have to shift everything below it down. Another big difference between bit memory and DBs is you can apply what they call aggregate data types or arrays and user-defined data types to data in DBs, which you cannot do in your bit memory, because bit memories are set up in the symbol table, and because of that it can only use the built-in data types. You cannot create your own types and impose that structure on bit memory. You can on a DB. Another good reason for it is you can create portable code where the DB goes with the FCs and the FBs to take that function to another PLC, either for a similar task or for a different task. So we can tie the the program's operation with the data that it operates on and port that from PLC to PLC with minimal change, usually not any change. We can store initialization values for startup. It's easy to capture parameters after commissioning so that you can start up your DBs with default parameters which you don't need to set anywhere in your program. It's set on startup and done. And another good reason is you can store and manipulate very large data structures very efficiently using DBs, either moving a whole DB around or moving data around using user-defined types or aggregate types. Right, if you're enjoying these videos, please like this video and subscribe. We will be bringing new information as regularly as possible. Thank you for watching.